Okay, welcome to the deep dive. We've got a really fascinating collection of sources here today. Thanks to you for sharing them.
Yeah, it's quite a mix. We're seeing desert life, some deep ancient history, geology, even these really delicate ecosystems.
Right. And it might look like a jumble, but I think our mission here is to, pull out key insights from all this and maybe find some surprising connections between them.
Exactly. How the really old stuff, the geology, connects to life today, how people lived here ages ago,
Mm.
and what nature's resilience might tell us.
Yeah, maybe find some of those aha moments hidden in the details. So let's jump right in with desert life. That first stack of sources talks a lot about surviving against the odds. And the acacia tree is a great example they bring up.
Oh, the acacia, yeah. It's remarkable. And the sources point out something really odd. It flowers in late June.
Late June, you mean peak summer, hottest time, evaporation going crazy. Why would it do that?
Well, this is where its incredibly deep history comes in. Acacias go back something like 250 million years.
Ah.
Yeah, back to Pangaea, the supercontinent.
Right, before everything drifted apart.
Exactly. So acacias were already around. The ones here probably have roots, ancestrally speaking, in Eastern Africa.
Okay, in Eastern Africa, that's more of a monsoon climate, isn't it?
Precisely. So late June, there is rainy season, or the edge of it. The tree evolved to flower then, expecting water.
And when it got here, maybe seeds carried by animals, the sources mention that, right, needing to pass through their gut.
Yeah, exactly. Gazelles, ibex, that sort of thing, deposited elsewhere. A bit messy, but it worked.
So the tree arrives here, June rolls around, and it's like, where's the rain?
Still waiting, and that probably explains the roots.
Yes. The sources said they spread out incredibly wide, right? Not just deep.
That's the key thing. Maybe 35 meters wide for just a 5 or 6 meter tall tree. That massive net is how it catches whatever little water there is.
That's amazing. And there's that cultural angle, too. The wood for the mishkan, the tabernacle.
Right, and that idea that the desert shapes people, even leaders, it adds another layer to this tough little tree.
It really does. And there are, what, 4 species just in Israel?
Right.
And hundreds worldwide.
Yeah, about 800 globally. Apparently, telling them apart is tricky. You need like 7 different things to look at. Shape, leaves, fruit, bark, the whole deal.
Okay, so the acacia is one specific survivor.
Right.
But the sources also talk about desert wildlife generally. And the big challenge isn't just scarcity.
No, it's the instability. That's what the sources really emphasize. Years of drought, then suddenly, whoosh, a massive flood.
Right, that unpredictability. Adapting to extremes is harder than just adapting to low.
Exactly. Contrast that with a salt marsh, which the sources also cover.
A salt marsh sounds like the opposite of stable in a desert.
Well, surprisingly, it kind of is. It's formed by trapped floodwater that evaporates, leaves salt behind.
And the salt helps.
Yeah, it pulls moisture out of the air or from underground. Hygroscopic, I think the term is, so it keeps the ground damp for plants, even with hardly any rain.
Like that magical forest near Elat they mentioned, surviving on almost nothing.
That's the one. A stable little pocket. Sadly, the sources also say it's mostly gone now. Development, hotels, airport.
A reminder of how fragile these places can be.
Hmm.
Okay, let's shift gears way back in time now. The geology. The sources dive deep into the Syrian-African rift.
Oh, yeah, this is huge scale stuff. And the key thing, it's still happening right now.
Still active. How do we know?
Well, think about it. Rivers are always dumping sediment into the valley. If it wasn't still sinking, it would have filled up ages ago. It would be flat.
Like Holland, as the source put it.
Exactly. Its very existence proves it's still dropping, and it's doing 3 things at once, according to the sources.
3 things.
First, it's opening up. Africa and Arabia pulling apart. A fetal sea, they call it, like a baby ocean starting.
Okay, pulling apart. What else?
It's sliding. The eastern side, Jordan, is moving north faster than the western side, Israel.
Right, causing that big offset, like 105 kilometers.
Yeah, something like that. Out of a total gap of maybe 140 kilometers, about 35 kilometers is that sliding.
Okay, opening, sliding, and the third.
The eastern side is also moving up. Higher mountains on the Jordan side compared to the Israeli side. They give numbers like 830 meters versus maybe 92 meters. It's a significant tilt.
Wow, pulling, sliding, lifting, all at once. That's a lot of action.
Immense forces. And it explains the rock layers we see exposed. The sources use this great 3-layered cake model.
A geological cake. Okay, what are the layers?
Bottom layer. Igneous rock, formed from magma cooling. Really old Cambrian, like 600 million years ago.
Okay, base layer, 600 million.
Then continental sedimentary rock on top, sandstone mostly, laid down maybe 550 to 520 million years ago, probably by rivers on land.
Now the top layer.
Marine sedimentary rock, much younger, maybe 100 million years old, tells us the whole area must have sunk below the sea for a long time.
So magma base, then land deposits, then it sank and got sea deposits.
Pretty much. Then much later, maybe 25 million years ago, faults started breaking it up. But the big one, the main rift, really took over about 5 million years ago.
And that's when rivers started carving down, exposing all those layers.
You got it. And in some places, you can literally step across 500 million years of time, walk from the 600 million year old stuff onto the 100 million year old stuff.
That's mind-bending. Puts things in perspective.
And it all follows those simple rules. What goes up, erodes. What goes down, fills up.
Even things like the mushroom rock.
Yeah, that's erosion too. Wind and water hitting softer layers. But also chemical stuff, gypsum and salt reacting with water, sort of corroding it.
Okay, from geology, let's zoom into ancient human history. The copper mining in Timna. That's a big focus in the sources.
A huge deal back then. Copper was critical. And the sources say it formed there in two main ways.
One was from an old sea, right? Dying algae, leaving copper bits behind.
Yeah, that left lower grade stuff, less than 1% copper, like 0.7%.
Yeah.
Then you had hydrothermal vents, hot water dissolving stuff concentrating the copper.
And that made much richer ore.
Oh yeah, like 30, maybe 40% copper. Big difference.
So here's the weird thing that sources point out.
Yeah.
Why did modern mining go for the low-grade stuff?
It seems backward, doesn't it? But the high-grade stuff was in these narrow veins, hard to find and dig out with big machines. The low-grade stuff was spread out everywhere.
Ah, so you could just scoop up huge amounts of rock, and every scoop had some copper. Easier for mass extraction.
Exactly. Practicality over purity, in a way.
And the sources really push back on the idea of who worked there, not slaves.
That's a key point.
Yeah.
The evidence, clothes, food, buildings, it doesn't look like slavery as we picture it. They mentioned this term genio, which was maybe more like a dependent status, apprenticeship, not necessarily chattel slavery, more complex.
Okay, so not just anonymous labor. Who were they then? Midianites?
Probably not. The sources say there's almost no Midianite pottery found there, just one piece apparently.
Wow, one piece?
Yeah. The pottery they do find, plus biblical references, the strong suggestion is they were Edomites.
Edomites, like from the Bible.
That's the connection they make. King Solomon's navy sailing from near Eilat in the land of Adam. Maybe this Timna community was like the nucleus of the Edomite people.
In copper back then, it was like oil today. That's what a source said.
He who owns copper owns basically that which radiates on everything else. Yeah, it was fundamental tools, weapons, farming, stability, everything.
And they had this relationship with Egypt.
Yeah, symbiotic almost. The Egyptians needed the copper, they were the big market, but also, the sources argue, you needed an empire like Egypt to really make large-scale copper production work.
How so?
Well, smelting copper was invented way earlier, maybe 5th millennium BCE, but it didn't take off for like 2,000 years. Why? Because you needed the organization, the demand, the distribution network that only a big state and empire could provide. Egypt was one of the first.
Fascinating. That lag between invention and widespread use needed a whole empire to bridge it. Okay, let's shift again, back to nature, but a very different ecosystem. The coral reefs. Why are they even here?
Good question. It's kind of unlikely given the desert surroundings. The sources give two main reasons, both tied to the rift.
The geology again. Okay, reason one.
The steep drop-off. The sea floor plunges really deep, really fast right off the coast because of the rift.
Right, down to like 770 meters quickly.
Yeah. So when sand or sediment washes in, it just tumbles down into the deep abyss, doesn't hang around near the surface to cloud the water.
And corals need clear water.
Absolutely vital. They have these tiny algae, zooxanthellae, living inside them, making up like 93% of their mass. The algae photosynthesize, make sugar for the coral. They need sunlight, murky water, no sunlight, no food.
Okay, so the steepness keeps it clear. What's reason two?
The desert itself. Because it's so dry, when floods happen, not much water actually reaches the sea, and what does reach it is mostly sand, not many nutrients.
Ah, nutrients feed other algae, the kind that do cloud the water.
Exactly. So the water here is oligotrophic nutrient poor, which counterintuitively is great for the corals because it keeps the water super clear, unlike the Med, which is nutrient rich but cloudier.
So steep drop-off plus dry desert, perfect clear water for corals.
That's the formula. And it supports incredible biodiversity. Get this, 25% of all fish species live on reefs, but reefs are only 0.25% of the oceans. Tiny area, huge life.
Amazing concentration. And the colorful fish. Why so bright?
Communication, sure, attracting mates, warning rivals, but also, the sources say, the coral is so colorful, the fish need bright colors just to stand out.
Like the toucan needing the rainforest background.
Kind of, yeah.
Mhm.
Plus, the reef structure gives them loads of places to hide. It's a whole interconnected system.
It's under pressure now. Big time.
Immense pressure. The visitor numbers are staggering: 1.7 million people a year on just 4.5 square kilometers.
And the health stats are grim. Flip from mostly alive to mostly dead.
Yeah, the sources cite studies showing that reversal. From maybe 70% alive in the 60s, 70s to maybe 70% dead now. It's worrying.
Bleaching's a big factor, right, from warmer water.
It is. Stress makes them expel the algae, they turn white. It doesn't kill them instantly, but weakens them badly. But there's a twist here.
Oh,
These specific corals near Eilat are tougher than most when it comes to heat.
really? How tough?
They can handle water up to maybe 33.6 Celsius,
Wow.
way higher than many other reefs globally.
Why? How did they get so tough?
It goes back to the last ice age. About 20,000 years ago, sea levels dropped hugely, cut the Red Sea off from the Indian Ocean.
Okay.
Conditions got harsh in the isolated Red Sea, hotter, saltier, most stuff died off. Then, 11,000 years ago, seas rose, reconnected.
And the Red Sea got repopulated.
By larvae drifting in from the Indian Ocean, but they had to pass through the bottleneck, the Bab el-Mandab Strait, where water temps were naturally very high, around 32 degrees C.
Ah, so only the naturally heat-tolerant larvae made it through that bottleneck to repopulate the Red Sea.
Exactly. So the corals here today are descendants of those tough survivors. They've got inherited resilience to heat.
That's incredible. Natural selection in action over millennia.
It is. But even with that resilience, they face other threats now: suntan lotion, pollution, acidification, and these huge development projects nearby, like NEOM. The scale is just massive.
So resilient, but maybe not invincible against all these combined pressures.
Right, which leads to those conservation efforts the sources mention, like building artificial bird habitats.
Yeah, compensating for lost natural sites like that salt marsh.
I know.
Not trying to perfectly restore,
Yep.
but create something functional.
Exactly, and tailoring them. Specific ponds for shorebirds, lakes for fish eaters, planting the right food sources, time for migrations. It's creative conservation.
Moving beyond just restoration, because sometimes you can't go back. You need new solutions. Wow. Okay. We have covered so much ground, from trees adapting over millions of years to corals surviving ice ages to ancient mining to modern conservation tactics,
It really shows how connected it all is, doesn't it? The geology shapes the land,
which allows specific hardy life forms to thrive, like the acacia or these corals.
which then supported ancient human societies like the copper miners, who were themselves linked to larger empires.
And now these same ancient resilient ecosystems are facing completely new pressures from us today, requiring these really creative, sometimes artificial conservation responses. It's quite a sweep of time and interaction.
It really is. Deep time, human history, and present-day fragility all woven together.
So what's a final thought to leave folks with? We've talked a lot about resilience.
Yeah, maybe that's it. Resilience in the trees, the corals, even the conservation efforts. What does that deep history of adapting and surviving tell us about how we need to face today's environmental challenges? Can we be as resilient, as adaptable?
Or perhaps think about the desert itself. The sources touched on it as this, harsh but formative place, forging life, shaping landscapes, maybe even shaping people in those ancient stories. How does that idea of the desert as a tough teacher square with how modern activities are impacting that very same environment?
Definitely something to chew on.